Hello everybody, welcome to the video, and today we are focusing on elastic versus inelastic collisions. Right, so basically what we look at when we are dealing with elastic and inelastic collisions, we look at the kinetic energy, which is ek. This is the formula for kinetic energy, right? This is the formula right here, and this is what we use to test if something is elastic or inelastic. This is the formula right here, the formula for kinetic. All right, so now let me try to differentiate between elastic and inelastic collision. So basically, before I start, I want you to know that the difference between the two is that they are opposite, right? They are opposite, so there's no huge difference, right? So I'm gonna start with elastic collisions. Now, elastic collisions are collisions whereby the total kinetic energy before the collision is the same as the total kinetic energy right after the collision. So, meaning that if you were to calculate the kinetic energy of A and you add it with the kinetic energy of B just before the collision, it's going to be the same as the kinetic energy of A and the kinetic energy of B right after the collision. So meaning that if before the collision you got 100 joules, you're also gonna get 100 joules right after they have collided. But then you have to know that in real life, elastic collisions are rare. Alright, so let us jump into inelastic collisions. Now, inelastic collisions are collisions whereby the total kinetic energy of the system is not the same before and after the collision. So meaning that I've just made an example. So meaning that if you were to calculate, this is before and this is after. If you were to calculate the kinetic energy of the system, so meaning that the kinetic energy of A and B right before the collision, and you get 100. This means that if you were to calculate the total kinetic energy of the system after the collision, you wouldn't get 100. But then what causes this? What is the cause of something to be an inelastic collision? Well, let us jump into it. Alright guys, I'm gonna try to explain to you what causes something to be inelastic, or what causes collisions to be inelastic. So the only thing that causes some collisions to be inelastic is that actually most, not some, because most, yeah, because in real life we have inelastic collisions. It's really rare for collisions to be like perfectly, no, it's we rarely get these, right? But I'll come back to it, right? So the only reason we would say something is inelastic is because it has lost energy, right? It was 100 joules here, but now it's less than 100 joules here. Now, really, what causes this loss of energy is the fact that when two things bump into each other, or maybe let us just say these are cars bumping into each other, they're gonna make a lot of sound and they're gonna produce a lot of heat, because they are just bumping into each other. And also the energy, some of the energy is used in deforming the cars, because I've yet to meet a collision of cars that ends with both cars in perfect condition. So I really hope I witness that before I die. Alright, we are doing a quick recap on elastic versus inelastic collision. For elastic collisions, the total kinetic energy of the system is the same before and after the collision, right? But then for inelastic collision, the total kinetic energy of the system is not the same. It varies, it differs. So thank you for watching. I'm gonna see you next time. Do not forget to like and subscribe.